Hi guys, I am Yashodhan Agnihotri, a final year student at IIIT Pune, and I will be your host for today. Welcome to our channel, Learn Competitive Programming with CodeChef. On this channel, we post weekly problem explanations and concept videos. Also, if you are interested in competitive programming and want to master data structures and algorithms, this is the place for you. So, what are you waiting for? Click on that subscribe button and kickstart your journey towards competitive programming today. So, the problem in discussion today is from the recent April Cook-Off, and the problem name is tree distances. The difficulty level of this problem is easy medium, and the prerequisites are basic knowledge on trees. Let us check out the problem statement. A tree is defined as a connected undirected graph with n vertices and n-1 edges. So this is the basic definition of a tree. So the distance between two vertices in a tree is equal to the number of edges on the unique simple path between them. So we are given two integers x and y. We have to construct a tree with the following properties. The first one, number of pairs of vertices with an even distance between them should be equal to x. So there must be x pairs having even distance between them, and number of pairs of vertices with an odd distance between them should be equal to y. So the number of pairs with odd distance between them should be y pairs. By a pair of vertices, we mean an ordered pair of two, possibly the same or different vertices. So since now this is the problem statement, let us consider a quick example. So we have x is equal to 2 and y is equal to 2. So basically we need a tree which has two pairs with even distance between them and two pairs with odd distance between them. So let us draw such a tree, 1 and 2. So this is the example of such a tree. Now let us see what these pairs are. So 1 comma 1, this is the first pair with even distance, and 2 comma 2, this is the second pair with even distance. It is said that the nodes can be the same, right? Now let us check out the nodes, the pair of nodes with odd distance between them. So 1 comma 2, this is the first pair, and 2 comma 1, this is the second pair. These two may be the same pair, you may think, but here we want an ordered pair. Therefore, these two are different pairs. So hence this tree satisfies our answer, and hence this is the correct answer, right? So now we have seen the problem statement and the sample case. Now let us proceed to the solution approach. Starting with the solution approach, now let us try and figure out how many total number of pairs there will be. So let us take an example. So we have n nodes with us. So here let us write the possible first node in the pairs, and here let's write the number of possibilities for the second node. So for the first node in the pair, we have n possibilities, and for the second node we also have n possibilities, because as you saw that we can consider the same node having a pair. So 1 comma 1 is a valid pair. Also we can also consider ordered pairs, right? So 1 comma 3 and 3 comma 1, these are different pairs. So n into n, so therefore we will have a total of n square pairs, right? So what do we do with this? So the first condition that comes to mind is that x plus y should be equal to n square. So if x plus y is not a square number, then there is no way possible then that we can make a tree such that x is the number of even distance pairs and y is the number of odd distance pairs. So if x plus y is not equal to n square, then the answer is no. Now let us try and actually construct a tree which has x plus y as a square number, and x is the number of even distance pairs and y is the number of odd distance pairs. So first let's consider that if there are at least two nodes in a tree, okay, so 1 and 2. So if there are at least two nodes in a tree, then the tree is 100% going to have at least two levels, right? 2 levels. Because if a tree has one node, then it will simply have just one level. So the tree needs to have at least two nodes to have two levels. Because if the tree has n nodes, say we can have something like this: 1, 2, 3, and up to n. So this is also a valid tree, that we have n nodes and we still have two levels. Now, having two levels, let us try and calculate the number of odd distant pairs in this tree. So let us see. We have this type of tree. So what are the number of odd distant pairs? So let us consider this as level 0 and let us consider this as level 1. If you see, an odd distant pair here is a node in an even level and a node in an odd level. We cannot have two nodes in the same level because if you see 2, 1 and say 3, so this has distance 2 between them. Therefore, it is an even distance pair, right? Not an odd distance pair. So nodes in the same level won't make an odd distant pair. So nodes in an even level into nodes in an odd level will make an odd distance pair, right? So here the total number of pairs having odd distance between them is 1 into n minus 1, right? But since we are considering ordered pairs, therefore our answer is 2 into 1 into n minus 1. So this is total odd pairs. Now you will soon see what we gain from calculating this, because from calculating this we can see if we can actually set the number of odd pairs to y by choosing a suitable value of n. So let us see. So how do we use the odd pairs information or observation to construct the tree that we need? So what we know is that x plus y needs to be a square number. Therefore, square root of x plus y will be equal to n, that is our number of nodes. So we start with the following tree, that we have 1 as the root and all the other nodes are in level 2. So this is the tree that we start with. What we do is we calculate the number of odd pairs in this tree, right? Now, if you see here, the number of odd pairs are 1 into n minus 1 into 2, right? So this is the least number of odd pairs that a tree can have. Now we just check if this value is equal to y. If it is, then this is our required tree. But if it is not, then what we do is we remove one of these nodes and we put it to the lower level. So we make this as our tree. Then we again check our number of nodes, number of odd pairs. So now the number of odd pairs for this tree, it will be the number of nodes in even levels, that is 2, into the number of nodes in odd levels, that is n minus 2 into 2. So we again check if this is equal to y. If yes, then this is our required tree. And also one thing to be noted here, that we don't need to worry about the value of x, because if the value of y comes out to be correct, then the number of even pairs will always match, because n square minus y is equal to x. So we just need to fix one of these values and the other value will automatically come out to be correct. So how we can do this? It's very easy. So we set even is equal to 1 and odd is equal to n minus 1. Then we simply apply a while loop and we check that if odd into even into 2 ever becomes equal to y. If yes, then the tree is possible. If no, then the tree is not possible. Simple as that. So now, having seen this solution approach, let us move on to the C++ implementation. Let us start with the C++ implementation. So first we take input x, y, that are the two numbers x, which denotes the number of even distant pairs in our tree, and y, which denotes the number of odd distance pairs. So here first we check if x plus y is a square number. So we do that by applying a simple while loop where n into n is less than x plus y, then we increment n, and finally we check if n into n is not equal to x plus y, then we simply output our answer as no, because as we saw that x plus y needs to be a square number for the tree to be possible, because there are a total of n square pairs in the tree. Now, first and foremost, let's handle the corner case of x plus y is equal to 1. So, for 1, there will obviously be just one node. And if x is equal to 1, in that case, the answer will be yes, because then the pair will be 1, 1, right? But if y is equal to 1, then there will be no odd distant pairs. Therefore, in that case, our answer will be 0 and such a tree is not possible. So this is handled. Now let us move on to the actual part of constructing the tree. So here, as I said, we first set the number of nodes in even level to 1 and the number of nodes in odd level to n minus 1, since there are a total of n nodes. So also our n is greater than or equal to 2, hence we have at least 2 levels. So here I first set this boolean variable pos, which is equal to false. Now entering this while loop, we check if number of odd pairs is it equal to y, and how are we calculating the number of odd pairs? Number of nodes in the even level into number of nodes in the odd level multiplied by 2. So these are the number of odd pairs. So if they are equal to y, then our answer is possible, and then we will break it because we no longer need the loop. And if it is not, then we will simply increment even and decrement odd. Why are we doing this? We are removing one node from the odd level and we are putting it into the even level. Now, finally, we will check if our answer is not possible, then we will output no. Else, if our answer is possible, then look carefully what we do. First, we output the number of nodes, that is n. Then we output n minus 1 lines where we output the details of the edges. So first, we will output the root, that is 1, and the root and the second level, that is 1 and I plus 1. So this will be level 1 and level 2. This level is the number of nodes that we have detached from level 2 and moved to level 3 to facilitate our equal to y condition. So this is the output for that. So basically, after outputting this, we get a tree which has x even distant nodes and y odd distance nodes. So if you submit this, you will get an AC. So I hope you understood the video, and thank you for watching.